Hey, Algebra 2 folks. Happy day. I hope your day is going really well. This is our last section before we move into our review for our Chapter 5 test. Very proud of the work that you've done so far. I think that you're going to be really successful on this test and do really well. So let's move into solving radical equations. We're kind of taking all of our rational exponents, radicals, and all the solving that you already know how to do and kind of mushing it together. So this is like the culmination of all that we've been working on. So what are we really looking for when we solve a radical equation? We are really looking for the roots. And you guys know roots as x-intercepts, right? So I'm going to write several different things. X-intercepts. And you're also looking for the solutions. So we're going to be talking about these kind of as functions today, looking at them on the graph, seeing how we can solve using the graph, and how we can check using the graph. So what would a solution look like if we were to graph the equation as a function? The solution would, again, it would look like the x-intercept. So remember, your x-intercept is where it crosses the x-axis. I know, bringing you back, right? Oh, it always boils back down to that graph. So what are our steps to solving a radical equation? Let's talk about this because it's a little bit different than just solving your normal equation. We just have one added step here, and we have a step that's going to be very important for checking your work. So our first step is to isolate the radical. Our second step in solving a radical equation is to eliminate the radical using opposite operations, and we'll talk about what that looks like in a second. Number 3 is to solve for the variable. And your last step here, number 4, is going to be your most important step here because you could end up with imaginary solutions or not real solutions if you're not careful. So our last step is to evaluate to check your solution. So let's try. We're going to evaluate two different ways. We're going to be evaluating by plugging back in, right? Taking that solution and plugging it back into the top equation. And we're going to be evaluating using our graphing calculator. So let's take our first one. The square root of 3x plus 6 equals 0. So if we were to follow our steps, we're going to first isolate our radical here. So I'm going to move my 6 to the other side. So I have the square root of 3x equals negative 6. So I isolated my radical. Now I'm going to eliminate the radical. Because this is square root, I'm going to use opposite operations to square both sides. This eliminates my radical here. So I have a 3x equals negative 6 squared is the same as me saying negative 6 times negative 6, which gives me 36. And now I'm going to solve for the variable by dividing. So I have x equals 12 here. Now, the important thing here is that we need to evaluate to check our solution. So let's see, when we plug it back in here, I'm going to plug in 12, add 6 equals 0. 3 times 12 is 36. We'll call this the check. Plus 6 equals 0. The square root of 36 is 6. 6 plus 6 here is 12. It's not 0, is it? It sure is not. So this does not check out. And I want to show you, you can't really see that graph there, so I'm going to pull it up in Desmos here. We're going to plug in this very graph, the square root of 3x plus 6. And if you see from our graph here, we don't have a real solution. Our radical function never crosses the x-axis, does it? So I'm going to say for my answer, or for my solution, come back here, is I'm going to say there's no real solution. No real solution there. Yeah. All right, let's look at example number 2. I have the cubed root. The cubed root of 2x plus 1 minus 2 equals 3. I'm going to follow my steps again. So I have isolate the radical. So I'm going to get rid of this 2. So I have the cubed root of 2x plus 1 equals 5. And I'm going to cube both sides. That's solving for the, or that's eliminating the radical. Because my radical is a cube root, I'm going to do the opposite, which is raising to the third power. So those cancel, those get eliminated. 2x plus 1 equals 5 cubed is 125. Now I'm going to subtract 1 because my next step is to solve for the variable. Whoops, 124. And divide by 2. So x equals 62. All right, that sounds pretty good. Let's see if it checks out. So here's my check. The cubed root of 2 times 62 plus 1 minus 2, does that equal 3? Let's see, 2 times 62 is 64. Yeah, 64 plus 1 is 65. Minus 2, does that equal 3? Let's see. Oh, yeah, the cubed root of 60. Okay, I had to pause. Sorry, I got a text message. Y'all, you have to tell me when I'm doing this wrong. Okay, x equals 62. When I plugged this back in, I did not get 60. I don't know why I got 64. Y'all, I'm sorry. That's why we do pencil, right? Good thing pencils have erasers. 2 times 62. I'm going to pull my calculator out here. 2 times 62 is 124 plus 1 is 125 minus 2 equals 3. The cubed root of 125 cubed root is 5 minus 2 equals 3. All right, that works. 3 equals 3. We are checked out. So I'm going to pull up my graph because we checked out algebraically. Now I want to make sure that I check out graphically. So I'm going to pull the cubed root. I never remember where it is. There it is. The cubed root of 2x plus 1 outside minus 2. So let's talk about this, because when I plug in this value 62, it should equal 3, right? So let's think about that. If I go all the way over here, trying to scroll out so we can see everything together. If I plug in this value of 62, which is about, yeah, right here, it should equal 3. Look at that. We're right there. That's awesome. Oh, I was on it. There it is. That's great. So we can prove that it equals 3 here. Great job. All right, let's move on. I'm going to be checking my math along the way since I'm having trouble multiplying today, y'all. All right, so here's another example. A little bit crazy. Solve the fourth root of 3x minus the fourth root of 2x minus 5 equals 0 and check your work using Desmos and evaluation. So if we were to solve this, we can do it a couple different ways. I think the easier way here, it says first to isolate our radical. Well, we have 2 radicals. So what I'm going to do is I'm going to put this one on the other side, the fourth root. Probably didn't make that best decision there. So I have negative fourth root of 2x minus 5 equals negative fourth root of 3x. I'm going to divide by -1. Let's deal with only positives. All right, so I have the 4th root of 2x minus 5 equals the 4th root of 3x. That's nice. I have the same root on both sides, so I'm going to eliminate the radical, step 2, by raising everything to the 4th power. That's great. That just gives me a regular equation. So I have 2x minus 5 equals 3x. Subtract our 2x on both sides. -5 equals x. And that works. Let's plug it back in, see if it works here. The 4th root of 3 times -5 minus the 4th root of 2 times -5 minus 5. Remember, we're dealing with even roots here. So if we have the even root of a negative number, it's going to be that imaginary number. Just keep that in mind. We have the 4th root of -15, minus -10 minus 5 is -15 again. Yikes. What do you think is going to happen here? We got some imaginary numbers going on. Let's see what this looks like on the graph before I keep going, because I feel like I'm not going to check out. So let's see. The 4th root of 3x minus. You guys are probably way faster at plugging this stuff in than I am. The 4th root of 2x minus 5. Oh, look at that. That is crazy looking. That function will never equal 0. It's never going to have a root. Looks like it has an asymptote there, doesn't it? So we're going to say here again, let me pull my document camera back up. No real solution. It looks at the beginning like you have something good going on, but then once you plug it back in, you get square roots of negative numbers or 4th roots of negative numbers. There's no real solution here. So no bueno. All right, I want you to do example 4. Try that using the graphing calculator, and then we're going to move on to the back here, okay? So let's do this one here. Let's do this one here because it's a little bit crazy. My first step was isolate the variable or the radical. We've kind of done that, but we've left ourselves with this over here. So we're going to see what this looks like. When I eliminate the radical by squaring, what happens is I have 3t plus 1 on this side, and I have 2 minus root 3t times 2 minus root 3t on this side. So we may have to do a couple of fun things together. So I'm going to FOIL. So I have 4 minus 2 times the square root of 3t minus 2 times the square root of 3t plus 3t, because it pops out, right? Equals 3t plus 1. All right, so let's work this out, see what we get. I'm going to isolate my radical again by subtracting 4 and subtracting 3t. Okay, that's nice. Those cancel. So I have a -3 equals -4 times the square root of 3t. Grab some extra paper here. We're going to keep going. Don't worry about that. This is my scratch paper. So I have -3 equals -4 times the square root of 3t. I'm going to isolate my radical again. I still have a radical, so I'm still having to deal with it. Negative divided by negative is a positive. 3/4 equals square root of 3t. Now we're going to eliminate the radical by squaring. So I have 9/16 equals 3t. Divide by 3. So when I divide by 3, we're really multiplying by a third, right? Don't forget that, multiplying by a third. Now we can cross cancel. 3/16 equals t. Oh man, that's rough. Okay, because I'm a little bit weary of some of the fractions, I'm going to go to my Desmos and let's see what this looks like, okay? So we have the square root of 3x. Remember, anytime that you plug it into Desmos, we need to make sure that you're using x and not another variable unless you define that variable. All right, so look at what I'm doing here, and this is kind of cool because what I'm doing is I'm plugging in two, oops, see, I did it. I'm plugging in two equate or functions here, and I want to see where they're equal, just like when we were solving systems of equations. I want to see where they cross, and look at that. It is when t equals 3/16. It's right there. That's awesome. So we actually do have an answer. That is your answer. That's great. Perfect. So we're good on that one. So anytime you have something that looks like this, you can just see on the graph where they intersect. That's another way to solve. So let's look down here. I'm gonna, let's look at this one right here, looking at it on the graph, and we'll see what that looks like. A little bit simpler. One side of the equation is 25, and one side of the equation is x plus 100. So I want to know, where's my x equals 25? My y equals 25. Where did it go? Will it not do it? Maybe not. I have to see where it is 25. So at 25, what is my answer here? It's about 11.118. Wow, cool. So we can solve that algebraically too, but that'll help too. Okay, so let's look at this one here. It was the second one on your notes. Let's see this, 5x plus 3 and the square root of x plus 11. So we're looking at where they intersect. It's the x value where they intersect, and so that should be 2. So let's pull this back over here. This is the one that I'm looking at. I want to see if my answer is 2 here. That's kind of cool. Let's see if that works. Radicals are already isolated. I'm going to square both sides. So I have 5x plus 3 equals x plus 11. Now I'm going to isolate my variable. I'll solve for my variable, right? So I have 4x equals 11 minus 3 is 8. Look at that. X equals 2. That's what we were trying to prove. Nice. Okay. So let's look at this down here. This real world exploration. Okay, real world exploration. Let's read this together, and then you're going to try these out on your own for the remainder of the notes. So the velocity of a free falling object can be determined from the equation v equals the square root of 2 times g times h, where v is the velocity measured in feet per second. G equals 32 feet per second. Y'all, this is a constant, right? It's always true because it's gravity. And h is the distance in feet the object has fallen. From the height from which a rock has been dropped, or find the height from which a rock has been dropped if it strikes the ground with a velocity of 50 feet per second. So that means I'm looking for what the height was when velocity is 50 feet per second. So I'm going to plug in my known values, right? This is 50 here, the square root of 2. This is always 32, and I'm looking for the height, right? When v is 50. So think about this in terms of v is y and h is x. So let's solve this. 50 equals 64, square root of 64h. I know the square root of 64 is 8. So I have 50 equals 8 times the square root of h. Isolate our radical. 50 divided by 8, I'm going to reduce that to 25 over 4 equals the square root of h. Eliminate the radical. So I have h equals 625 divided by 16. What is that number? So I have 625 divided by 16. It's about 39.06. So the height at which the object was dropped was at 39. Now I'm going to check this on my graph here. And look here, I've plugged in my function already, my radical function. So this is the function of an object being dropped, right? And I want to know what the height is. So my y value is actually going to be 50 because that was my velocity. And I want to know what my x value is. So if I look here to check at 50, I can kind of see it there. Am I checked out? It's at 39, yeah, 0.0, whatever that is. Let's see if I can get it right at 50. 0625. There it is, right there. So I know that my algebra is working out. So you can always check yourself using your graph as well. Okay, so go back and do the next 3. An object is dropped from a height of 50 feet. So in this case, you're just plugging in that 50 into the h. So it's going to look like this. Velocity equals 2 times 32 times 50. So you're just evaluating that. An object is dropped from a height of 200 feet. So same thing, you're finding the velocity. 2 times 32 times 200. And then an object an object that was dropped strikes the ground with a velocity of 120 feet per second. So I wonder if it was dropped from higher than 39 or lower than 39 feet. That'll be our question as we come together from your notes. So I'll see you soon.